So dear students, today I will discuss about complex form of Fourier series. Okay, till now we have discussed about Fourier series, but the series was in terms of sine and cosine. But here we will discuss in terms of complex form. That is, you know that cosine and sine are represented by the Euler's formula. That is in the form of exponential, complex exponential form. That is e to the power ix or e to the power I theta, something like this. Okay, so what we have till now we have discussed about these kinds of series. Suppose there is a periodic function f of x, and this can be expanded like a0 by 2 plus summation n is equal to 1 to infinity a n cos nx plus b n sin nx. So in this form we have already discussed. Okay, in this form we have already expanded a Fourier series f of x within a given interval. Okay, but you know this cosine and sine can be represented in terms of exponential form. You know that cos nx can be written as e to the power inx minus e to the power plus e to the power minus inx divided by 2, and sin nx can be written like this, to the power inx minus e to the power minus inx divided by 2 equal to y. Okay. So this is how we can write sine and cosine in terms of complex exponential form. Okay, so if you substitute this cos nx and sin nx here, then you will get a complex form. You will get a complex form. Okay, and we have discussed earlier in the last class a very important problem, and we have got a series like this. Okay, so we have discussed this problem in the last class to understand the Dirichlet's condition. And today also I will take this problem again to understand the complex form of Fourier series. Okay, and we have for this function f of x the Fourier series like this. We have derived in the last class that the Fourier series for this function will be half plus 2 by 5 into sin x plus sin 3x plus 3. Now if you put here this sin x and this sin 3x as exponential form, like if you put this sin x as e to the power ix minus e to the power minus ix divided by 2y. Similarly, sin 3x as e to the power i3x minus e to the power minus i3x divided by 2y. Then you will get a complex form from here. Okay. So this is one method. If you want to get the complex form of Fourier series, you can substitute this sine or cosine in terms of exponential form. But this is not our aim in this class, because you know the integration. The Fourier series is basically the process of finding the Fourier series basically involved some difficult integral. So our aim is to make easy our calculation. Okay, so in that purpose we will discuss about this complex form of Fourier series. So if you avoid the complexity of this integration, then we want to solve the, or we want to find out the Fourier series directly in the form of exponential form. Okay, because you know always integration will be easy for exponential form. Okay, the integration of exponential function is always easy than sine or cosine terms. Okay, so we want to find out the complex form of Fourier series directly. So first we want to find out the Fourier series in terms of exponential form, then we will move to the sine and cosine form. So what we have done earlier we have find out the Fourier series in terms of sine and cosine terms. If you want, you can also substitute here in the final expression in the form of exponential, or like this by using Euler's formula. You can write but this is not our aim, because our aim to make our calculation little easy. So what we will do, we will find out the Fourier series first in the form of exponential form, and then we will move to here. Okay, so let me find out that, let me tell you how you can find out directly the complex form of Fourier series, so in terms of e to the power ix or something like that. Okay, so in that case, let us assume the Fourier series instead of this. This is the general form of complex Fourier series. This is actually in terms of sine and cosine terms, but let me assume that the complex form of Fourier series f of x can be written like this: summation n is equal to minus infinity to plus infinity cn e to the power inx. So instead of this, we can write the Fourier series like this also. Okay, so what will be the expanded form of this? So this will be something like c0. If you put n equal to 0, then it will be just c0. If n is equal to 1, it will be just c1 e to the power ix. Again, if you put n is equal to -1, that we can write it like that: c minus 1 e to the power minus ix. Okay, similarly, plus if you put c2, then it will be e to the power i2x. Then again, if you put minus, then it will be -2 e to the power minus i2x. So all the terms will be present here, plus terms as well as the minus term. Okay, so this is the compact form, and if you want to write it in expanded form like this, so you can write it. Okay, so what we have to find out here also, we have to find out c0 cn, as here we have found out a0 an bn. Here also we have to find out this c0. Okay, c0 and cn, because if you put minus n, then we will also get c minus n. So in the expression of cn, if we put minus n instead of n, then we will get the expression of c minus n also. So no need to find out c minus n separately. First we will find out c0, and then we will find out cn. Okay, so it will automatically tell you what will be the expression of c minus n. Okay, then if you put the value here, you will get the Fourier series in terms of exponential form. Okay, and then if you want, you can move from here to here also. So this path will be little easy than this, because here the integration will be more easy, because the exponential term will be involved in the integration. Okay, so now let me find out the coefficients. Okay, so here you know already, you know that how you can find out this an and bn. And to find out an and bn, what you have to know here, the average value of cos nx and the average value of sin nx. Okay, we have used the average value of cos nx and average value of sin nx, because what we have done, we have multiplied this series with cos nx, and then integrate from minus pi to pi. So that will basically that was basically the average value of this function between the limits between the interval minus pi to plus pi. Okay, similarly here we will do also. So we will multiply this function. Instead of cos nx or sin nx, we will multiply by e to the power minus inx, to the power minus inx. Okay, so let me find out. So what we have just f of x is equal to something like this: c0 plus c1 e to the power ix, c1 e to the power ix plus c minus 1 e to the power minus ix plus c2 e to the power i2x plus c minus 2 to the power minus i2x plus dot. Okay, so this will be the term. Now what we have to do, we have to just and dot dot up to cn term. There will be cn also, cn to the power inx. So this term will be present also as n term. Okay, and it will go on infinity. Okay, so now let me find out the cn and c0. Okay, so if you want to find out, now what you have to do, you have to just integrate this function f of x integrate this function f of x dx between the limit minus pi to plus pi and take the average value. So it will be just interval 1 by 2 pi minus pi to pi f of x dx. This is the average value of f of x. So in this expression there will also be the average value. So it will be c0 to 1 upon 2 pi into integration minus pi to pi by f of x dx. But the other term, the containing other terms, okay, the integration for other terms will be 0, because all the expression in all the terms there will be e to the power I kx form. So we have e to the power I kx. You can see from here, in all terms there will be e to the power I kx. K is just integer, maybe a positive integer, negative integer, but not equal to 0, but not equal to 0. Okay, so if you find out the integration 1 upon 2 pi minus pi to pi e to the power I kx, that is the average value of e to the power I kx, this will always be 0, because why? This is 1 upon 2 pi and e to the power I kx, integration of e to the power I kx will be e to the power I kx by ik, and the limit will be minus pi to plus pi. And if you put here, you will get 1 upon pi ik. Let me take it outside, and inside we will put this 2, so it will be just e to the power I k pi minus e to the power minus I k pi divided by 2, and within this bracket this term is nothing but cos k pi, that is sin k pi. So you have to take this I also, it will be sin k pi, and you know sin all pi 0, and this k not equal to 0, because k is here in the denominator, so k should be not equal to 0. If k is equal to 0, then you will get just the first term. Okay, so I can tell you that this average value of this function e to the power I kx will always be 0. So here in all the terms there will be e to the power I kx. So the average value of all these terms except this term will be 0. Okay, so what will be the, and this in here not, there is no f of x, sorry, dx. Okay, if you multiply dx, there will be only dx, 0 dx. Okay, so now what will be the value of c0? 0. So you can find, yeah, so this 1 upon 2 pi 1 upon 2 allowed, so it will be just minus pi to pi f of x dx. So c0 into minus pi to pi dx means 2 pi. So c0 will be 1 upon 2 pi relation minus pi to plus pi x. Okay, so now what will be cn? So to find out cn, what we have to do, we have to again multiply this expression with e to the power minus inx. Okay, to the power minus inx. So now if you want to find out cn, so what we have to write again, that f of x is equal to c0 plus c1 e to the power ix plus c minus 1 e to the power minus ix plus c minus 2 e to the power minus i2x plus c2 to the power i2x plus dot dot. So this is the expression f of x. Okay, now what we have to do, we have to multiply with the power minus n, because here is the n term, cn to the power in. Okay, so if you multiply this expression with e to the power minus inx, and what you will get, and then integrate obviously. So f of x e to the power minus inx dx, then you have to take the average value, that means minus pi to pi, you have to integrate within this interval minus pi to pi. If you want, you can multiply 1 by 2 pi also, but it will automatically cancel out from the both side. So just let me simply write down minus pi to pi f of x to the power minus inx dx, and that will be what the right side you will get. At for each and every term, again you will get e to the power ikx form, because first term is c0 e to the power minus inx inx minus pi to pi dx, and for the second term you will get again c1 e to the power ix and e to the power minus I dx. So you will get all this term, and this will be 0. This will be 0 because here all here e to the power I kx form is there. Okay, and k is the integer value. Here also e to the power I kx, because n minus 1 is also 1 minus n is also integer, because n is integer here. So you will get this, but here you will get for this term e to the power inx and e to the power minus inx. So this will be 1. So here you will get only cn, and there will plus term also, and minus pi to pi e to the power plus inx and e to the power minus inx is 1. It will be plus dot dot again 0. All other term will be 0. So this all term will be 0. Here also the term will be 0. Okay, so this term will only survive. This term will only. So what you will get is minus pi to pi f of x e to the power minus inx dx equal to cn into 2. So we will get the value cn will be 1 upon 2 pi minus pi to pi f of x or minus inx. This is the cn. Okay, and what we have c0? We have c0 also. C0 we have c0 also. C0 is equal to 1 upon 2 pi minus pi to pi of x dx, and if you want you can find c minus n also, putting minus n instead of n. It's just 1 upon 2 pi integration minus pi to pi f of x or inx. Okay, so this is your Fourier coefficients or complex form of Fourier. Okay, so now let me again use this previous example to find out the complex form of Fourier series. Then we will move to here also. Okay, so let me first find out the complex form. So let me first find out c0. So what will be c0? So c0 will be what? C0 will be 1 upon 2 pi into integration minus pi to pi of x d. So we have f of x 0 for minus pi to 0. So only we have 0 to pi. So it will be just 1 upon 2 pi integration 0 to pi 1 into dx. That means only dx. So it will be 1 upon 2 pi and that will be half. And you have to remember one thing, that in the complex form of Fourier series you can see here that here is only c0. There is no c0 by 2, but in cosine or sine form there was a0 by 2. So please keep in mind here there is no c0 by 2. There is no half multiplication the first term. Okay, please keep in mind. So here c0 will be half. Okay, now what will be your cn? Let me find out cn. Okay, cn. Now what we have the expression of cn is just 1 upon 2 pi integration minus pi to pi f of x e to the power minus inx dx. And what is f of x? F of x is 1 for 0 to pi. F of x is 1 for 0 to pi, and otherwise it will be 0. So you will get just 1 upon 2 pi integration 0 to pi e to the power minus inx dx. So this is 1. So the integrand value will be just 1 upon 2 pi integration e to the power minus I pi inx minus in to pi. So if you want, you take this outside the bracket, minus 1 by 2 pi in. If you pi here, it will be minus in pi, but 0 is 1. Now we can find out from here that this value will be just 0 if n is even, if n is equal to even, because for even value this will be 1, e to the power minus I 2 pi 3 pi 4 pi 6 pi 7 pi, this will be 1. So if this will be 1, then 1 minus 1 will be 0. But if you take this as odd value like pi 3 pi 4 pi, then you will get minus 1 here. Okay, so this will be minus 1 minus 1, that will be minus 2, and minus 2, and these two, see, 2 will be cancelled out, and minus minus will be plus. So it will be 1 upon pi in. Okay, because here n is equal to, when n is, let me explain you. So what is e to the power minus I n pi? So let me verify this. If you put n is equal to 2, what you will get? You will get e to the power minus I into 2 pi. Then it will be what? Cos 2 pi plus I sin 2. Cos 2 pi plus I sin 2 pi. So you can see, if n is even, then this cos, this sin all pi 0, so this will be 0, and this cos 2 pi will be 1. So it will be 1 minus 1. For all even value, it will be this. But for odd value, suppose pi, so it will be cos pi plus I sin pi, and cos pi is minus 1, and sin pi is, sin all pi is 0, so it will be then minus 1. So for all odd value, you will get here minus 1. So minus 1 minus 1 will be minus 2, and this minus 2 and this minus 2 will be cancelled out. So it will be just 1 upon pi I. Okay, so this is c. And if you want to find out c minus n, then it will be just minus 1 upon, then here you have to put this plus, and then you can find out c minus n also. But we will use directly in the expression, final expression. Okay, so let me, if you want, you can find out. There is no problem. Okay, but you don't need to do this. Okay. So let me write this series now. Okay, by using c0 and cn, we can. So what we have, we had f of x is equal to just minus infinity to plus infinity cn e to the power I n x. Okay, now what will be the series? So we have just c0 is equal to, if we find out the c0 plus c1 e to the power ix plus c2 e to the power I into 2x. Okay, plus dot dot, and plus the minus term will be also there. So c minus 1 to the power minus ix plus c minus 2 to the power minus I2x plus dot dot. So let me find out. So c0 is what? C0 we have half. Okay, plus what will be c1? What will be c1? So we have cn is equal to 1 upon pi in, and this is only for n is equal to odd value. What we have, n is equal to odd value. Okay, so what will be c1? So if c1 is equal to just 1 upon pi I, 1 upon pi I to e to the power ix. But this term will be 0, because this is even term. So for odd term, again what we will, 3, for 3 we will get 1 upon 3 pi I into e to the power I into 3x. Okay, plus dot dot, what you will get? You will get here for minus 1, you will get again c minus 1, and for c minus 1, what you will get here, n is equal to minus 1, we have n is equal, so it will be minus 1 by pi I. That's why I told you that no need to find out into this integration again by putting here c is equal to minus 1 minus n, because we can write the whole series by using only the value of cn. Okay, so if you put here n is equal to minus 1, then you will get this minus 1 upon pi I, minus 1 upon pi I. Okay, and then what you will get, just for c equal to minus ix, and for c equal to minus 2 it will be 0. So what you have to put again, minus 1 upon 3 pi I per minus I into 3x plus dot. Okay, so this will be your series. Now if you If you want to write it in terms of sine and cosine, then you have to just arrange this series. So you will get like this, just half plus. So let me take 2 upon pi. Okay. So what you will get? 2 upon pi. So here is e to the power ix and here is e to the power minus ix. So what you will get, just e to the power ix minus e to the power minus ix divided by 2i. 2i, because here I have taken 2, so here I have to put 2 also. Okay. Then what you will get? Plus what you will get? You take this, then you will get 1 upon 3 into e to the power I into 3x minus e to the power minus I into 3x divided by 2i again, 2i again. Okay, plus dot dot. So you will get this, and this, you know, e to the power ix plus e to the power minus ix is sin x. So you will get half 2 by pi into sin x, plus you will get 1 by 3 into, this is nothing but sin 3x plus dot. So we have got this. Okay, see, this was our series of, basically half plus 2 by pi sin x plus sin 3x by 3. So that means, so we can find this series by using complex form of Fourier. So our path is different. So there the path was in terms of sine and cosine, and here the path in terms of exponential function. But here the calculation is a little easy, because here in the integration exponential term is involved, and the integration of exponential function is very easy. So this is the benefit of the complex form of Fourier series. Okay. So we have discussed a lot of things about Fourier series. Okay. And the thing about sine and cosine series and the complex form also. In the next class we will discuss. But you can see here that all the Fourier series that we have discussed here in the interval minus pi to pi. So now in the next class I will discuss about for any interval minus l comma l, for any interval, instead of minus pi comma pi, for any interval we will discuss about for minus l comma. Then we will discuss about odd function, even function, half range series. Okay.